Good evening, sir. Here we,
Speak loudly.
good evening, sir. Here we present to pressure agriculture system. Here is our group members: Protector, MSS Pereira, NLP J. Chandari. So, here is our class diagram. In our class diagram, we created a class called server. Server class has URL attribute and instance create server. When we create server class, we use single term pattern because when single term patterns we create a class and it make only one object, so we can save memory in server class, and server class get function connect to server for connect to the server and upload data to server. These functions use for when a user want to upload their details to server, use upload to server method, and notify automate system, get data, show data, get is instant, analyze data and show error message. This is used when user enter invalid data, then can so display error message. And other in our another class is user class, has attribute as username, password, server instance. Every user have instance in server class to access server, and login function and logout. And another class is location, automated system. It has location and server instance. Automation system class has function is do automated task. When is the location and what is the task we do, it's find automated system. And our another class is field station. In field station have field station ID, field station name, sensor,
Go down, it's okay.
and field station class inherit permanent fields and portable fields. Permanent fields has place name, and portable fields has location through GPS data. When we collect in another class called sensor, sensor has sensor ID and sensor name, time unit, time this class has status attribute. When we use when we want to switch on or switch off sensor, that is called status attribute. And another is time unit. We store when we want minutes, seconds or hours is stored in a time unit. And has handle data. Handle data when the sensor to sensor handle data function is different to work. And send data to field station, we can override details in this function, and sensor function inherit soil moisture sensor and soil temp sensor, air temp sensor and soil acid sensor. These all class give output data when we so we create another class called data. When the data class through, we can access geographical system, and we can draw map. So this is our class diagram, and I invite to another member to describe GRC parts.
I'm going to explain about CSSD class card. In server class, in website, there are responsibilities of server class, and these are the collaboration classes in server class. Show geographical map, get data from field station and upload to
Yes,
server.
okay, survey is fine. Go down. Go down. You added all the CRC cards for all classes, right? Go down is fine. Next part is okay. Sequence. Okay, start sequence.
In this sequence diagram, show user view the data through system. So when user get login and enter username and password, then the input get server and check it inputs are correct. If input are incorrect, display error message. If login success, return dashboard to user. Then user get view method. Then server get geographical views. And geographical system self-call draw map and return view to server, and server return view to user. Here is one
This is the sensor. In this sequence diagram, first
Speak low.
switch on the sensor and collect data, then handle the data and send it to field.
What is the
station.
class there? Go on.
Server.
Is that server class?
Sensor.
Okay.
Send it to field station, then get the GPS data, and then we got GPS data, then it upload to server. After this is a field condition.
Okay, next part.
One of the sequence diagram is certify automatic system to task when the sensor send data to server and server analyze this data. If automated task should be implement, notify automated system to the automated system, and if it is an automated system do automated task, if that task was success, return true, and it is task was failed, return false.
Here, the founder is the information to the display, and the information.
Zoom.
So, just the so it switches on, and then it collects the data, and then it handles the data. Then it sends the data to the field station. The field station gets GPS data and returns the data. Then it sets the sensor data, and then it uploads to the server. If the upload is successful, you return true. If not, you return false. For the user to log in, the user should log in. The parameters username and password are passed, and if it's true, if it's false, they show a error message. If not, you return to the dashboard where the user can view the get the view, and then it goes to geographical view where it draws a map, and then you return the map so the farmer can view that data.
So there is a
Personas.
Personas. Here we talk about manager working for a reputed food processing company. He's in charge of getting the crops for the products they manufacture. Since the company tries to maintain the best quality of products, so they want to get the best quality crops as they input. So the product should be manufactured at a steady pace, and therefore he has to make sure that there's a steady supply of the crop. To do so, the harvesting of the crop needs to be scheduled from different fields to maximize efficiency. He needs to be able to predict the
What are the frustrations? Frustrations did you mention? Motivations and frustrations related to this? No. Goal is fine. What are the issues? Did you mention issues and stuff? No. Next one. How many personas did you have? No, okay, next one.
The second one is about a farmer who owns a family operated farm. He grows many
Explain
different
goals.
goals. He wants to get the maximum possible yield and while maintaining the quality of crops. He also wants to use the resources at an optimum level without waste.
What is the environment? He looks at the system. Username and master. Okay, next one. High fidelity, low fidelity diagrams. Oh, there's another person. This is something similar like that, right?
Researcher. These are the goals to make fertilizers that increase the yield of the crop while maintaining
Speak loudly.
to make fertilizers less harmful to environment. These are the goals.
Okay, high fidelity, low fidelity diagram. you mentioned issues, right? Which scenario specific issues? Scenarios? Here. Yeah. Explain it.
Here is a scenarios and that illustrates issues. When we found one issue, when we create multiple server instance, can let into higher memory capacity in server. Then we get solution to use a design pattern called singleton design pattern. When we use singleton design pattern, server class would only create single instance for server in the system, and we another issue is higher power consumption of server due to the activation through the day. We give solution for that to switch on sensor only when sensor reads value. We use a variable called time interval. That sensor can be switched on only when reading have to be taken. And another issue we found, failed to upload data to server due to the signal drop and internet failures. We give solution for in memory storage using inside database to store that data in times short time, and one is issue is fixed and data issue is in memory will be sent to the server and it will be clear.
Yeah, explain quickly.
These are the interfaces of our system. Use for sign up.
That's fine. Next one. Next one. Why didn't you put annotations and stuff, right? Before hybrid and doplet, you have to use annotation and specify what's the next UI and something like that, right? It's not just the UIs. Okay, right, okay, next one, next one. You are going to load the map, something. Next one. Next one. Storyboards. Hold on. The same thing, right? No. Storyboard in the sense you have to have a separate story, you have to represent it locally, diagrams, preview. Not this one. Okay, hold on. That's all, is that? Okay, let's start from class diagram. Go to the class diagram. There are lots of problems here, right? Okay, wait. So why did you use this much of compositions for each and every classes, geographical information? So why did you maintain compositions here this much?
If all class has a whole quarter,
How come? Now without having server geographical system now, is that user has server? Is that so? And user is the only person who can create and delete server instance. And what's the purpose of having composition here? Is compositions.
if only one user have one user can access server instance. Server has both instance, and one user can access only one.
Association is enough, right? What's the purpose of having composition? It's the now relationships This is the most tight relationships, right? When we compare, so why do you use this much of strong relationships for here? This is now no point of having this much of strong relationships, right? It's not correct. You have to think about like association or something like that. And these classes are not enough. Now here, why did you use server? Server is not necessary for this one. You have to server in the sense it's a separate server instance who is going to cater for different applications. That means you are going to host or something, right? Now here, what are the things that you are going to perform using this server? You don't need to add servers for this one, right? How are you going to maintain DPS service and stuff? In this application they mentioned you have to add the GPS data and DPS service and specific things, right? Yeah, GPS service and stuff. Those things are not there, right? So you have to add, you have to improve. There are lots of things that you have to consider when you are going to implement this application. Now here they mention harvesting specific scheduler service. That is not there, right? You have to add the scheduling service for the harvesting specific things, right? Those things are there. Then they'll go down. No, class diagram. Up. Quickly drag it. Go down. No. So you have to improve a lot, right? This is not enough. Oh wait. Now in here, sensor. Okay, sensor has. Now this is fine. You have a superclass sensor, and there are different subclasses of for each and every sensor. You are going to maintain different status, current intervals, and stuff. Right? That is fine. But all other things we have to think about. There are no cardinality ratios. You have to add those things. Right? This is not enough. So you have to improve a lot, right? And even your sequence diagram, it is not in the satisfied state, right? Sequences are now in your data and GPS data. Go, where is the data and GPS data? Go up. Now why you have to have relationships like at least what's the data class, what's the data GPS data. Oh, no. Either it should now, according to your explanation, it should be generalization or something, right? Not, there are no relationships in between. No, here it's you are going to use again composition. It's not correct. Understood? Sequence diagram, yeah, it's not satisfactory level, right? So go to the sequence diagrams. Sequence diagram, you have to have a service controllers and right service layer implementation controllers sensors. Now we are going to how that request is sequencing for the in order to perform that particular functionality, right? So we have to serialization. If you are going to what are the serialization objects from the controller layer, how we are going to access the services and those things. Now this is not enough. Say a server user is there, service, what is the UI class, whether it's a controller class, those things, boundary classes, you have to specify, you have to use proper tool in order to draw these things. Now this is just drawing for here. Login is not necessary for this one. Login is something like now you have to think about what are the main business scenarios implement. Login is something supportive activity for this functionality. It is just authentication. You have to highlight other business scenarios in this sequence diagram, right? Go down. Here also, see, sensor data. You have to send whatever the past parameters, send data. Okay, field station, at least you have to have an object, model object in here inside this method, and what are the data things you are going to return, those things, right? So sequence diagram also not in the satisfactory state, right? You have to improve a lot. This is not enough. Even in your personas, you have to highlight what are the things that people, people's motivations, how people is going to really interact with the application, how that, what are the things that user is going to experience, right? What are the issues that user would suggest when they are going to use this system, and you have to mention how that they can, how you are going to overcome, what sort of solutions are you going to suggest in order to overcome these problems and stuff. You have to specify those things, right? And yeah, high fidelity, low fidelity diagrams, interaction design. You didn't mention anything, right? In your high fidelity, low fidelity diagram, you have to specify those things, interaction design, and those things are not there. So it's hard to give marks for these things. I am not sure whether how that now the UK professor is also going to review this, right? So we have to improve a lot. No, this is not enough, I am saying, right? And storyboard in this, you have to represent the story in rough sketch. In your high fidelity diagram, you have to use annotations, and you have to specify what are the things that you have to perform, the user is going to perform, what are the next screens and stuff, right? You have to represent how that user is going to interact when the application, when that user is now here you didn't use like a scenario flow. You have to have flow wise, just getting the sensor specificity. You have to implement a dashboard or something at least. User is going to interact dashboards, right? And experts are going to add details for this agriculture system. Agriculture system is a large scale, enterprise scale application. You have to think different areas. So this should be a portal like service. So you have to represent dashboard like application. Those things are there, right? Things are not here. That's right. Okay, that's all.